This is the last minute revision video on projectile motion, and let's first begin with trying to understand what is projectile motion. So when a body is thrown upwards in a direction different from the vertical, it is acted upon by the acceleration due to gravity g and hence moves along the curved path, and this is known as projectile motion. So if we are throwing an object not vertically upwards but at an angle, so in that case there's a force, gravitational force starts acting on it, and in fact that becomes the only force acting on it, and the object moves under the influence of the gravitational force alone, and that such type of motion is known as a projectile motion. A very important part, characteristics of projectile motion. So there's only one force, experiences only force, and that is gravity. Secondly, the horizontal velocity remains same throughout the flight. The reason being the only force is gravity, which is acting in the vertically downward direction. So there's no force acting in the horizontal direction. So whatever initial horizontal velocity is given to the object, it continues to move with the same horizontal component of velocity throughout its journey. No acceleration in horizontal direction because there's no change in horizontal velocity. So there's no acceleration in horizontal direction. Vertical acceleration, yes, and that is equal to minus g meter per second square. The path of a projectile is parabolic. When we derive the equation for projectile motion, we will understand this. And the last is horizontal and vertical motion are independent of each other. So one doesn't impact the other. Let us say an object performing projectile motion. It is thrown from here, it is thrown into the air from here, and this is this journey. The initial angle is, let us say, theta 0. Initial velocity is u. So the horizontal component here is u cos theta 0, and the vertical component initially is u sin theta 0. Now, as we discussed earlier, the horizontal velocity u cos theta 0 will remain throughout. Here also horizontal velocity will be u cos theta 0, here also same. So there is no change in the horizontal component, but the vertical component will keep on changing. Here you will have u sin theta 0, and as we go up, the vertical component here will become 0, and then again increase, and finally again over here it becomes u sin theta 0. So this is how the vertical component changes, the horizontal component remains same. How do we get an equation? Follow these three steps. First, for x, because we want the equation of motion in terms of y and x, the motion along the y-axis and the motion along the x-axis, because the object is moving along the y-axis as well as the x-axis. So what is the relationship we get? This is the relationship we get. How did we get this? For the x motion, use s is equal to ut. We can use this equation because the velocity is constant. So s is equal to ut. So x is equal to u cos theta 0. This is the horizontal velocity into time. So you get this equation. For y, use s is equal to ut minus half gt square, because acceleration is g in vertical direction, and minus g. So I put over here minus g. We have not taken s is equal to ut plus half gt square. It is minus gt square. And u, that is the velocity, the velocity in the vertical direction, the initial velocity in the vertical direction. Please note that we are looking at motion in the y direction. So here u is the initial velocity in the y direction, and that is u sin theta 0. So u sin theta 0 into t minus half gt square. Put value of t from equation 1 and equation 2. So from this equation, find out the value of t. T will be x upon u cos theta 0. Put that value of t in this equation, and you will arrive at this equation. And this is the equation of a parabola. As you can see, y is equal to x square. And therefore, this motion is a parabolic motion. Basically, what we have done is we have obtained a relationship between y and x in terms of initial angle theta 0, initial velocity u. So this equation, if you know the initial velocity u, and if you know this theta, then we can find out an equation for the motion, and we will be able to find out the value of y, vertical motion, vertical displacement, for every value of x. So if I know this x, I will know what will be the value of y. If the x is this much, I know my value of y. So this equation gives me how y changes as we keep on changing x, if I know the initial angle theta 0 and the initial velocity u. So that is the equation of parabola. Some terms related to projectile motion are flight time t. The total time for the flight is capital T, that which will be equal to 2 times small t, where t is the time required for the object to move from here to here. So 2t. When t is time to reach at point P from O. Use v is equal to u minus gt to find t. So we want to find out small t. Now this is, we'll look at the vertical motion, because the time is required to go up. What is the time required to go up? T is equal to u sin theta upon g. So you get value of small t over here, and t is equal to 2 times t. So this is the equation for flight time, the total time for this entire journey. To find out height h, the maximum height h, use v square is equal to u square minus 2gh. Please note that this is again displacement in the vertical direction, so we will keep on taking values of the velocity is in the vertical direction. So this u will be u sine theta 0, and this v will be 0, because when we reach over here, the velocity, vertical direction velocity is 0, and this is h. So put those values and you will get over here this equation for h. Range of projectile is this distance, the horizontal distance covered from O to this particular location. For this, we will consider, because the motion is in the horizontal direction, we'll take the horizontal velocity ux, which is u cos theta 0, and the total time of the flight, which we have obtained over here, t. So if I multiply u cos theta 0, which is the velocity throughout in the horizontal direction, and the total time which elapses when it starts from here and reaches over here, I can get the range, u square sine 2 theta upon g. So that's one more thing. For maximum value of r, if I want maximum value of r, what should happen? If I want to increase this r, sine 2 theta should have a maximum value, and sine 2 theta therefore should be equal to 1, therefore theta is equal to 45 degree. So if I throw the projectile at an angle of 45 degree, range will be maximum. The other point that we need to keep in mind is that value of r is same for theta and 90 minus theta. So if I take theta as 30 degree over here and find out r, if I take theta as 60 degree, that is 90 minus 30, again I'll get the same value of r, because this is because sine 2 theta, if you take theta as 90 minus theta, it is 180 minus theta, and sine theta is equal to sine 180 minus theta. Therefore we'll get the same value of r. Okay, last final point, Vx we know is u cos theta. The velocity, horizontal component velocity remains same throughout. As far as Vy is concerned, it is u sine theta minus gt. This is obtained by v is equal to u plus at. V is final velocity in the vertical direction. Initial velocity in the vertical direction is u sine theta 0. This is u minus gt. So this is Vx and Vy, which we can use at any particular location. And therefore the resultant of these two is Vx square plus Vy square. So we can take squares of this and we can get the resultant velocity at any particular location. And tan theta is equal to Vy minus x, so I'll be able to also find out the angle that it makes, so Vy upon x. So take ratio of these two and you'll be able to get the angle at which. So this is how we can find out the resultant velocity at any given location throughout the path of the projectile motion. Thank you.